Okay, graph shows the velocity of train during the first 30 seconds it leaves the station. So it leaves the station at 0, accelerates up here, gets to its maximum speed of k after 12 seconds, and then stays there for 30 seconds, or for complete 30 seconds since leaving the thing. Show the train travels a total distance. Well, we've got a velocity time graph here, and so the area underneath. So we have to work out the area of A and B. We've got to show that that is 24k total. So we've got area A equals, it's a triangle, so it's half the base times the height. So it's half times by the base, which is 12, times by the height, which is k. Half 12, so that'll be 6k. And then we've got to work out what B is. B is a rectangle, so it's not, don't have to half it, it's just the base times the height. And so it goes from 12 to 30, so the base there is 18 times the height, which is still k. So that equals 18k. We add those together, we get 24k. So we've done the first part. The signal box is 410 metres from the station. At the end of this 30-second period, the train passes a signal box. So signal box is it's like it's here. That's where the signal box is after 410 metres. We've got to find out what k is, and well, we know that 24k is the distance. We know that 24k must therefore equal 410. Got an equation, do the same thing to both sides. I want to divide both sides by 24, and that will tell me that k equals 17.083333. And we want to do 3 significant figures, so 1, 2, 3 figures. We look at the next number, it's an 8, so I do need to round it up, so that'd be 17.1. And we've got 6 marks so far. There's still quite a few more marks to come. Okay? And this is using the formula which is giving us now s equals ut plus a half at squared, and we'll see how we use this. So we've got a second train past the station at a velocity of 13. So that means it's the initial velocity is 13. So that's what u is. Some people write down stuva or suvat, but I don't know if you do, so I'll carry on like this. It accelerates at a constant rate after passing the station. Okay, it doesn't say what it is. That's going to be a is the acceleration. And 25 seconds later, so 25 is the t, it passes the signal box. So that means the distance is 410 meters. And then we just have to put it into here. The reason why Stuva works is it sort of collects all the information. Distance traveled 410, that's s. T is 25. U, the initial velocity, is 13. V doesn't tell us about, and A is what we're trying to find out, so we'll put a question mark, well, that's what A is. And we've given the formula, and the formula doesn't have a V, and so we really don't care about the V. So now we put everything in here. S is 410 equals U times T, so that's 13 times 25, and then plus a half times by A, which is A, and times by T, T squared, so it's 25 squared. So what I would do is just work out some of these. 13 times 25 is 325, plus a half A times, that'll be 625. And what I'm going to do is do it in a few steps. There's lots of probably shorter cuts, but it's the way I'll do it. I'm going to take away 325 from both sides to start with, and that will leave me that 85 equals just this bit over here. So it's a half times by A times by 625. I'm then going to get rid of the half, so I'm going to times both sides by 2, and that will give me that 170 equals A times 625. I don't want A times 625, so I'm going to have to divide both sides by 625, and that will say that A equals 170 divided by 625, which is 0.272. So that's done that first bit. I'm going to try the Stuva thing on this bit. So we've got Stuva. where s is our distance. Now we've got, again, before it passes the signal box, and the signal box we know is 410 meters, so that's 410. We are told, no, we're not told t, we want to find out what t is, so that's going to be our question mark. It passes the station at 15 meters per second, so u is 15. We still don't know about v, the final velocity, but we do know the acceleration is 0.4. So now we can put it into here. We've got our formula at top, so s equals, that's 410, equals ut, so that's 15t, because we don't know what t is, plus a half times acceleration is 0.4 times by t squared. So right now I've got myself, we know it's going to be quadratic. I'm going to tidy up this bit here a little bit. Let's give 410 equals 15t plus 0.2 t squared. That's a half of 0.4. And now I'm going to get everything onto the left hand side. I'm going to take away 410 from both sides so that it'll be all on here, but I'm going to write it down the other way around. So 0.2 t squared plus 15t. But I'm going to take away that 410 from both sides, so it'll be a minus 410 over here. So minus 410 equals 0. Because whenever we get a quadratic, we always want it to equal 0. Little trick, I don't really like the 0.2, so I'm actually going to times everything through by 5, because that means I'll have just a complete t squared. 15 times 5 is 75t, minus, it'll be 410 times by 5 is 2050, and that equals 0. And it says to the nearest second, so I'm expecting it to be, to have to use the formula. So I know my formula. It's normally x equals, but these are now t's. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. And a is 1, and b is 75, and c is minus 2050. And so that will give me a t equals minus b, so that'll be minus 75, plus or minus the square root of b squared, which is 75 squared, minus 4 times the a is 1 times by the c, and that's negative, so it's not the minus button, it's a negative button, 2050, and that's all over 2a, so it's 2 times 1, so that's 2. And I need to put that into a calculator exactly like it is there, and that gives me that t, when I put the plus in there, it gives me 21.289. But I also want to put the minus in there, because I don't know which one's going to come first. Or, if I put the minus in, minus 96.289. Obviously, it's not going to be minus 96. Therefore, it's going to be this 21.289. It says to the nearest second. So 21.2 to the nearest second is 21 seconds. And again, that's quite a tricky question. A quadratic one, as soon as we get a quadratic, we always want to make sure we end up getting it being equal 0 like that. And that's question 10 done.